Push that rock with some math. Let's talk even and odd functions. So even functions are defined as functions where this is true. F of x is equal to f of negative x. And the famous example, of course, is the quadratic. X squared is equal to negative x being squared. So if I graph x squared, we all know it's a parabola. It looks like so. But notice if I reflect it left and right, so over the y-axis, then these points will all come over here and land on these points, and these points will land on that point, and the graph will not change. So that's the idea behind the even function, okay? So in trig, cosine is our famous even function. Let's look at the graph. We know that at 0, cosine maps to 1. At pi halves, it maps to 0. At pi, it's -1, and so forth. And we have the cosine wave. I'm going to go in the other direction. At negative pi halves, well, you're the same value you are at 3 pi halves because the angles are coterminal. Negative pi halves is coterminal 3 pi halves, so cosine has the same output. It's 0. And cosine at negative pi will be the same as pi because it's coterminal, and so forth and so on. And so here is a cosine wave. This is 2 cycles of the cosine wave. 2 cycles. Here we go. Now, the thing to notice is that if I were to reflect this over the y-axis, in other words, graph cosine of negative x, well, nothing would change. This point will land on this point, 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 and nothing's going to change. So cosine is equal to cosine of its negative input, and that's called the even identity. The even identity says that cosine of x is equal to cos of negative x, and it's true for its reciprocal. Sec of x is equal to sec of negative x. You know, if you think about the reciprocal graph, well, it's going to have asymptotes wherever cosine is 0, because when cosine is 0, there is no reciprocal. So it doesn't exist, secant doesn't exist at the roots of the cosine wave. But as you get close to 0 and you reciprocate, your numbers get very large. So as we get close to these roots of the cosine wave and we reciprocate them, the outputs are very large. So that means that there are asymptotes here, okay? And there's, of course, the reciprocal 1 is 1, so they share an output. Secant and cosine share an output at 0. And so the graph looks something like that. And then there's a going to negative infinity here because you're approaching 0 from the negative side. And there's, so here we have 2 cycles of the secant graph. But you notice if I reflect secant, this is y equals sec of x. But if I were to reflect it over the y-axis, well, this branch would come land over here, and this branch would land there, and this guy would just, you know, change places. So secant and cosine are both even functions. What about odd functions? Odd functions are defined as functions where the f of negative x is equal to the negative of f of x. And the famous example is x cubed. So negative x being cubed is the same as cubing x and then multiplying by -1. And you can see that when you graph y equals x cubed. If I were to graph it, we know that 0, 0, 1, 1, -1, -1, 2, 8, because if you cube 2, you get 8, and -2 would be -8. So the polynomial looks something like so. Now, if I reflect it over the y-axis, I get this reflection here. And this point will come over here, this point will come over here, this point won't move, this point will reflect over here, this point will reflect over here, and I have this mirror image like so. But what happens if I were to reflect it up and down? Oh, well, this branch would come, you know, line up with this one, and this one line up with that one. So reflecting it up and down is the same as reflecting it left and right. Reflecting it over the x-axis is the same as reflecting over the y-axis. That's the idea behind the odd function. And turns out sine is an odd function. So if we look at a sine wave, we know it looks like this. And there's 1 cycle of the sine wave. And if I extend it in the negative direction, it looks like so. So I have 2 cycles of the sine wave here. But what happens if I reflect it over the x-axis? Well, This point comes here, and this point comes up here, and this point comes here, and this point comes up here, and we have a graph that looks more like so. So that's y equals sine of, I reflected it up and down, so that's actually y equals over the x-axis, so that's y equals negative sine of x. But what if I did a reflection over the y-axis? In other words, I graphed y equals sine of negative x. Wait a minute. This point would go where? Oh, wait, I'm sorry, on the black. Where would this guy go? We're taking this guy and we're reflecting him over the y-axis. So where would he go? Well, he would land right there. So where would this point go? Well, he would land right here. Where would this guy go? Well, he would land right here. So you end up with the exact same sine wave. And that's the idea behind an odd function. So this is called the odd identity. And it says that sine of negative x is equal to negative sine of x. And it's true for its reciprocal. So cosec of negative x is equal to negative cosec of x. It's also true for tangent. If you think about the tangent wave and how it looks, negative x is equal to negative tan of x. And cotangent. Cotangent of negative x is equal to negative cotangent of x. And that's the odd identity. Math made simple. Simple math.